Hello, I'm Mira.
And I'm Ereen.
My name is ADRIANA BATRISYA.
Hi, I'm AISYAH.
Differentiation is a fundamental concept in calculus that involves finding the derivative of a function. The derivative measures the instantaneous rate of change of a function with respect to one of its variables. In practical terms, it tells us how a function changes as its input changes. The derivative of a function fx is written as f prime x or dy over dx, and it represents the slope of the tangent line at any point on the curve of the function. One of the techniques of differentiation is power rule. This is the most common and basic rule used to differentiate polynomial. The formula is d over dx, x power n equal to nx power n minus 1. Secondly, we have constant rule. The derivative of a constant is always 0. Thirdly, product rule. This is used when two functions are multiplied together. The formula is y prime equal to uv prime plus vu prime. Next, quotient rule. Use this when one function is divided by another. The formula is y prime equal to vu prime minus uv prime divided by v power of 2. Lastly, chain rule. This is used when a function inside another function. The formula is dy over dx equal to dy over dz multiply dz over dx.
Hi everyone, today I'm going to explain how to find the derivative of two functions. Let's start with question A, which is y equals 4x plus the square of tangent of sine of x plus 3. We begin by taking the derivative of 4x, which is simply 4. Now for the second part, the square of tangent of sine of x plus 3. We need to use the chain rule. First, we take the derivative of tangent squared, which is give us 2 times tangent. Then, we multiply that by the derivative of tangent, which is secant squared. Finally, we multiply again by the derivative of sine of x plus 3, which is cosine of x plus 3. So, the final answer is 4 plus 2 times tangent of sine of x plus 3 times secant squared of sine of x plus 3 times cosine of x plus 3. Now, let's look at part B. We use quotient rule. So first, the derivative of the top part, or we call it u. Then, the derivative of the bottom, we call it v. That's the formula of quotient rule, which is v times u prime minus u times v prime over v square. Now, we follow the rule. Multiply the u prime by the v. Then, subtract the u multiplied by v prime. All of this goes over the square of the v. After that, we simplify it. Remember, just simplify the top one. After simplifying, we get the final answer, which is 6x times e to the power of 2x minus e to the power of 2x minus 2, all divided by the square of 3x plus 1. Thank you.
Question 3. First, find the quotient rule. And then find product rule. Simplify it to negative 10y. Now we differentiate the functions which give us as a written there. To make it less complicated, differentiate one by one. Then differentiate the right side. So now we are able to find dy dx as shown here. Then transfer the element that has no dy dx to the right side. To find dy dx, we have to factorize the element that has dy dx. Then finalize your answer as shown.
Question 4 is 4 sec 80.99 minus 2 over sec 80.99. So first, we need to define the function by changing the value of 80.99 into x in the equation. We need to change it into x to the power of 1 over 4 minus 2x to the power of negative 1 over 2. Second, we need to find the derivative by differentiating to get f prime x. So, we will get 1 over 4x to the power of negative 3 over 4 minus x to the power of negative 3 over 2. Third, we need to identify the initial value xo, which is 81, and delta x is 0.01. Then, we substitute the values into the equation of f prime x. It will become 1 over 4 times 81 to the power of negative 3 over 4 minus 81 to the power of negative 3 over 2. And the answer will be 23 over 2916. Fourth, the answer obtained will be substituted into the equation of f prime x times delta x to find the x. And the answer will be 23 over 291600. Finally, all the answers will be substituted into the equation f 80.99 equal to f 81 times dx. For equation f 81, we use the original equation given, while dx is 23 over 291600. After pressing it in the calculator, we get the final answer and round it off in 3 decimal places, which is 35.778.
Conclusion, we have understood that implicit differentiation is used when it's hard or impossible to solve y explicitly. It helps to find dy over dx even if y is not alone. Moreover, implicit differentiation allows us to find derivative of equations with both x and y mixed together. As for the recommendation, practice more different types of equations to get used to the steps. Thank you!